So, welcome to Probability and Set Theory, Lesson 2 for Shaughnessy's class. You've got a few different things. Keep in mind I don't have the disclaimer sheet handy. Please to show up to class. This is looking more at sets. Now, in the last video or the last class, we looked at just some definitions of sets. Empty set, universal set, all that sort of thing. This is all about the operations on sets. These are the two operations you need to be comfortable with: intersection and union. Okay, so it's a little bit simplified. In fact, it's quite a bit simplified. This is just what we have to do, okay, in this course. So logical operators. First off, and means all of the described options are satisfied. So you have to think about the word. Now let's just look at those words and or, because they come up in this idea. With and, it means you've got everything. The example I use is I need to take and select candies, and I need red candies and green candies. It means I need red and green. I don't have the option of only having part of them. And I know that sounds goofy, and I know that sounds obvious, but that's what's boiling down here. So if I say set A is 2, 4, 6, 8, and set B is 1, 2, 3, 4, what elements are in the set described as A and B? So what are in A and B? What are in both sets? You've got everything satisfied. And in A and B, so that's what I'm just going to write here, A and B, okay, I start taking a look at the elements, and I ask myself what elements are in both. 2 is in both, as well as 4 is in both. Nothing else is in both. So since 2 and 4 are in both, then A and B contains the elements 2 and 4, okay? Because it's got to make sure that both are satisfied, okay? When you start talking about or means at least one of the options is satisfied. You may have both, you may not have both, but you may just have at least one. You've got something. So if I take the same two sets, A being 2, 4, 6, 8, and B being 1, 2, 3, 4, what elements are in A or B? Well, I'm just looking for what elements do I have. A or B, okay? I've got a 2, I've got a 4, I've got a 6, I've got an 8. As well as I've got a 1, the 2 I've already talked about, 3, and the 4, which I've already talked about. So in this set here, A or B is going to contain 1, 2, 3, and 4, as well as 6 and 8. Basically, it's just a single copy of each of those elements. You don't list them twice, okay? So you don't say 2 and 2, but that's or. Now this goes back to this whole idea of, and or, language, that sort of thing. We are comfortable with this. If I take Archie comics, for example, if I say Archie is going to take Betty or Veronica to the prom, at least one of the options is satisfied, so I've got that. So I've got at least one of them satisfied. If I'm to say I'm going to take Betty and Veronica, I suppose you could really strongly, and I would be all with you, making the case that nobody's satisfied. However, it means that you've got both. So Betty on one side, Veronica on the other, that sort of thing. That's just an Archie comic reference. If you don't know what I'm talking about, it's just a comic book. So going through with this sort of idea, union of sets. Okay. Now these are the two things that we really want to look at today. The union of sets. The union of sets is the elements that are in at least one of the listed sets. Okay. So union. Okay. That it has a symbol that looks like this. Okay. It almost looks like a U, but it's not. Okay. It doesn't have that little tadger, and in fact, I have to stop often and think about it. You're not doing a union. You're not doing a U, sorry. So you're looking for the union, at least one of them. So, given A is 2, 4, 6, 8, and B is 1, 2, 3, 4, what is in the set A union B? Okay? So when I start looking at this set, I start to say, okay, well, at least one of the sets is possible. This is essentially, I'm satisfying or. Okay? In union, I'm satisfying or. So going through with this, I look at A union B. Oops. It's very hard not to do that little tadger. A union B is going to be the 1, the 2, the 3, the 4, the 6, and the 8. We had that above in the OR situation. Okay. okay? But that's what union is doing. It's trying to say what things are mentioned. So I've got them in at least one of the two sets. I may have them in both, I may not, okay? Going through and looking at this second example, from the universal set of integers from 0 to 9, so 0 through 9, okay? 3, 5, 6, and 9 are A, and B is 1, 2, 3, 4, 5. What is given by the set? And once again, A union B. Okay? So I look there. What elements do I have? Okay? And I ask myself which ones are in at least one of them. So I've got 1, I've got 2, 3's in both, which is great. 4, I've got 5 in both, which is great, as well as 6 and 9. So I have 1, 2, 3, 4, 5, 6, and 9. Okay, that's what's in the union. And the union of these two sets is just basically you're mashing them together, and anything that's listed is counting. Okay, intersection. Intersection is the opposite. So as we were talking and or above. Since union was or, this is probably going to be and. That's an assumption, and you're right. Okay, the intersection of sets includes all the elements that are in all of the considered sets. The intersection abbreviation is like this. It's just basically like the union symbol upside down. Okay, so given A is 2, 4, 6, and 8, B is 1, 2, 3, and 4. What is in A intersection B? Okay, so when I start looking at that, I'm looking for the elements that are included in both. So A intersection B is going to be, I've got 2 in both, I've got 4 in both, I have a 6, 8, a 1, and a 3, but it's not in both, so I'm not going to include those. So A intersection B is going to be 2 and 4, okay, and that's it. Okay, when I look at this from the universal sets of 0 through 9, A is 3, 5, 6, and 9, B is 1, 2, 3, 4, 5. What is in A intersection B? Okay, and so I just say, well, I've got what's in A intersection B. I'm thinking that this is going to be kind of like an and so I look from there. A intersection B is going to include, my pen's not working, include the elements. I've got a 3 in both, then a 5 in both, and that's it. So these are going to include the elements 3 and 5. Okay, and that's all that ends up being used. Now, once you've got union intersection, how do I remember? Okay, well, first off, I remember a couple things. I've got these two symbols. Okay, I've got union, I've got intersection. On the formula sheet it will tell you, but I see this as union. So that symbol, which is here, kind of looks like a U, so I see that as union. Okay, so that means the other one, once I've got that one, the other one is intersection. Now, that's on the formula sheet, so that itself is kind of irrelevant. Then you start asking yourselves, well, how am I going to tell? And I like to think of the and the or. Okay, I truly think of the and the or. And means I've got this and this happy, or means I've got one of these two things happy. I'm not really sure. Now, the one that's and is the intersection. That's this symbol or this symbol. This is intersection. That's and. And so what I see in my head is and. Because I draw, when I'm writing, I do an A like that. A, intersection, B. Okay? So it's very similar to an A is how I write it. So I see that as and. Now I know because it's the opposite of this one that it's intersection, but when I'm thinking about and or, I see intersection as and, which means I've got to have both satisfied. So that one's and then once again the opposite. So if this one's and, then this one must be or. Now I don't know if that's helpful to you or not, but that's how I think about it, and it really works well for me. So once you're going with different ideas and different sets, you've got all sorts of different things that happen. Okay. Once I look at this, I'm going to set A. Okay. So I'm going to give you, given set A is the factors of 24 and set B is the multiples of 3 less than 30. Okay? Now, you need to understand what those two sets are. So before I do any of these A through F things, what are the factors of 24? This is the set 1, 2, 3, 4, 6, 8, 12, and 24. Okay? So you've got to figure that out. Now, if you're having trouble with the factors idea or what they're talking about, please get help. Multiples of 3 less than 30 are 3, 6, 9, 8, 12, 15, 18, and so on and so forth. So we've got that. So in this particular case here, I just want to look at these, and I want to draw some things, okay? So I've got set A as the factors of 24. Set B is the set of multiples of 30. Draw a Venn diagram for the following. And if I say, oops, maybe I'll put that as a draw a Venn diagram. Now what happens in this Venn diagram is I've got my universal set, and I've got a circle for set A and a circle for set B. Okay? Now, this is set A, this is set B, and I got to ask myself, well, A includes 1, 2, 3, 4, 6, 8, 12, and 24. The multiples of 3 less than 30 also include 3, 6, 9, 12, and so on and so forth. So things like 6, 12, 24 are in both sets. The elements from A that aren't in that intersection, that's 6, 12, 24. It's hard to read. You've got the 1, the 2, the 3 is here, the 4, the 8, and that's it. Okay? Multiples of 3 are 3, 6, I've got a 9 in that one, 12, 15 in that one, 18, then 21, 24, 27, and less than 30, so that's where I'd stop. So I've got those elements in there, okay? So it becomes a little bit more complicated. Drawing the Venn diagram a little bit larger probably would help, but so that's what's going on. I'm just going to make it a little bit bigger for a second. Okay? You've got your universal set. Okay, you got your universal set. One circle for A, one circle for B. The 3, 6, 12, and 24 are in the center. 3, 6, 12, 24. 1, 2, 4, and 8 are within A, but not elsewhere. 9, 15, 18, 21, and 27 are within B, but not elsewhere. So you've got this as your Venn diagram. Okay? Now going through with this idea, then you've got some other things that happen. So if I look at B, I say what is in, so the same idea, A union B. Okay? So what is A union B? Now I have to ask myself, what does that mean? Well, I see union as or. So what is in A or B? And what I'm going to do for this one, A union B, is I'm just going to list all these numbers that are over here in this Venn diagram. So A union B is going to be 1, 2, 3, 4. Then I've got 6. Then I've got 8. Then I've got 9. Then I've got 12. Then I've got 15. And I've got 18. And so on and so forth. And I'm just listing all the numbers that I would have. Then I got 21. Then I got 24. Then I got 27. So basically all the numbers that I've got, that's what's in A union B. Okay? If I ask A intersection B, okay, what is in A intersection B? Well, that's the ones that are in both lists. That A intersection B, once again, is the 3, 6, 12, and 24 that I have in the intersection of the two circles. That's, you can think of intersection of the two circles where both circles are satisfied. Okay, that's what's in your intersection. Then I can ask you questions like this: are A and B disjoint? Now you have to remember from your previous definitions, what does it mean to be a disjoint set? Okay, disjoint means there's nothing in common. Are these two disjoint? Well, no. 3, 6, 12, and 24 are in both sets, so these are not disjoint. And you can go on, and you can go on, and you can go on. Now you can ask questions like this too. Is A a subset of B? Okay, which means that all of the elements in A are also in B. And the answer there is no. Look at the 1, look at the 2, look at the 4, look at the 8. The 1, 2, 4, and 8 are not in B. So A is not a subset of B. Okay. You could also ask, is B a subset of A? Okay. Are all of the elements in B also in A? Well, the 9, the 15, the 18, the 21, and the 27 aren't. So this, once again, is a no. Okay. So just don't forget you've got all these symbols, and they all look very similar. Okay. So you've got that sort of idea. Now, you can do a whole variety of things with these operations. Given the Venn diagram below, and I'm going to draw a Venn diagram. I'm going to try to draw it neat this time. There's my universal set. Okay. I've got set O, which is Euler's spans. I've got another circle intersecting set E, which is Eskimo spans. Okay. And I've got some numbers. I know that 23 of the people I surveyed were just Euler's spans, 8 were both, 47, and then there were 14 outside. So I've got this particular Venn diagram. Okay. And once again, this just comes down to the language, what's going on with the language for this question. Okay. So given that Venn diagram, okay, there it is. How many cheered for the Oilers only? Okay. Now you have to read it very clearly. Oilers only. That's the 23. Okay. That section there is Oilers only. How many people cheered for the Eskimos? Well, the Eskimos are this whole circle. So there's 47 that were only Eskimos fan, plus 8 that did both. So you've got 47 plus 8, or 55. Okay, this C is just because I was dictating. How many people were surveyed? Well, basically this is how many do I have in total. I have 23, 8, 47, and 14. I got 55, 75, 78, 88, 92. I have 92, and I just added up all those numbers. 92 people were surveyed. Now, I can ask it to you in words, or now that you have the symbols, I can ask the symbols. How many are in O intersection E? Okay. O intersection E. So that is O and E. That means there's some in O and some in E. How many are in both? 8. Okay. How many people are in O union E? O union E is everything that's in this 8-looking thing, this figure 8 sort of idea here. So I've got to figure out how many are there. And if I add those up, it's 50, 70, I think it's 78. 78. Okay. So you've got that. It's just adding the 23, the 8, and the 47. How many people are in E prime? Okay. Or the complement of E. Or, said another way, how many people are not in E? Well, there are 14 that are just outside that I haven't looked at really much. Plus these 23 that aren't Eskimo fans, they're Oiler fans. So I add them together, and 23 plus 14 is 37. So there are 37 in E primed. Okay? And so you've got that sort of idea. So using the Venn diagram, keeping in mind the symbols, keeping in mind the language, you can just make that work. Okay? And we can do a whole variety of different things. Okay? Given this Venn diagram, maybe it's moving around. Given this Venn diagram, and I'm going to give you a larger Venn diagram. There's my universal set. Inside in there, I've got 3 circles. Okay. One is E for English, one is M for math, one is P for physics. So I'm just going to write English, math, physics. Physics is P, math is M, English is E. Just as a legend, just so you have it. Now looking at this is my universal set. Numbers that I've got are 97 here, then 34, 6, 4, 3, 29, 11, and 12. Okay? Context from this, these are the number of students enrolled in these courses. So from there, you can ask yourself all these questions. How many students are in physics only? Well, physics is this circle. There's 11 plus 12 plus 4 plus 3 in physics, but this is physics only, so that's just the 12, because that's the part that's in physics and no other circles that I've got. B, how many students are in English? Well, that's this whole circle here, the 34, 6, 4, and 3. Keeping in mind it's not saying English only, it's saying all of this. I'm just going to add this up. 34 plus 6 is 40, plus 4 is 44, plus 3 is 47. So I end up with that. How many students are in math or physics? So it means math or physics or both. Now keep in mind it's not mentioning anything about English. I'm worried about math or physics. They could be in English. They also could be blue-eyed. They also could be hockey fans. They also could play guitar. It doesn't say anything about that. So because of that, that's not a limiting factor. How many are in math or physics? Well, I've got 29 just in math, plus this 11, 4, and 6. So 29 plus the 11 is 40, plus 4 and 6 is 50. So I've got 50 students in math. Or, okay, physics. Now keeping in mind, in physics I've got 12, the 11, the 4, and the 3. So you think, okay, I'm just going to add those together. So 50 plus the 12 and 11 is 23, 26, 30. And you think, oh, that's it. There's 80 students. But it's not right. These 11 and 4, they've been counted twice. You either don't count them originally, or you have to subtract them once. Because I counted them once in here, and once in there. I counted the 11 and 4 twice. So I have to undo that. So I can either subtract the 15, or I could have not added the 15 to one of them. However you do it is fine. But I just want to make sure that that's clear. So 50 plus 30 is 80, minus 15 is going to be 65. There are 65 students in math or physics. So I just really quickly want to caution you, because those are the sorts of mistakes that we do see. In D, how many students are in math and English? Now once again, it's not talking about physics, but it's and English. So math and English, there's this 6 and this 4. That's it. You're looking for people that are math and English. That's the intersection. So 6 plus 4 is 10. There's nothing that's counted twice, so that's easy. How many students are in English and physics only? Okay. So now there is a little bit of a wording issue here, and I wrote this, so this is my fault, I guess. English and physics only. Okay, I'm going to say this is English only and physics only. Okay, sorry, or physics only. Okay. Okay, so English only or physics only. Okay, I know what I wrote, or that's what I intended, because that's what I've got on my board. On my notes. So English only is 34. Physics only is 12. And so that's what you're going to add together. That's going to be my 46 for my answer. That's what I meant to write. I didn't write that very well. Okay? If I would have done it exactly as it would have said, how many students are in English? Okay, here's another way. English and physics only. Okay? So physics only is 12. Means they're not in English. If I use the word and, it means I want them in physics only and I want them in English. So if I say English and physics only, if I say it that way, the answer is 0. I don't have anybody that's in physics only. And if they're only in physics, how the heck could they be in English? So That's a miswording of E, but nonetheless it's there. Okay. F, how many students are there in total? Well, I just add up all the numbers here. So I have 34 plus 6 plus 4 is 44, 47. Okay. This is going to be another 40, so that's going to be 87 plus 12 is going to be 99 plus 97 is going to be 196. I have 196 in total. Okay. There are 97 that aren't in these three courses, and you can say, well, what's going on? They're taking something else. They're taking chemistry, or they're taking rock and pop, or they're taking something else. Okay. So there you go. And that's this whole idea of the intersections in the union. Now, going along with this, and I know everybody's getting tired, heck, I'm yawning here. In a survey of 100 people, it was found 47 liked Doctor Who, 13 liked both Doctor Who and Phineas and Ferb, and 22 liked neither show. So this is making you having to take some statistics and build the equation. Okay? So you can go through. You've got a circle for Doctor Who. You've got a circle for Phineas and Ferb. Okay? And you've got your universal set. Okay? 13 liked both Doctor Who and Phineas and Ferb, so 13 must be here. 22 liked neither, so the 22 must be out there. So those first two pieces of information are dealt with. Okay? Now, 47 liked Doctor Who. Now, this 13 is counted in that 47. So 47 liked Doctor Who. It's not Doctor Who only. 47 liked Doctor Who. So 47 includes that 13. So I do 47 minus 13, and that tells me this is 34. Okay? So there's 34% that when I asked them, do you like Doctor Who, and do you like Phineas and Ferb, they only said yes to Doctor Who. From there, I need to take the idea of what's going on with this question. It's 100 people in total, so 100 minus these will tell me that final circle. Okay? So 100 minus 34 is 66, minus 13 is going to be 53, minus 22 is going to be 31. So there must be 31 in there. I just did the subtraction. There were 100 people in total. 100 minus these ones. Okay? So how many students liked only Phineas and Ferb? 31. How many students liked Doctor Who only? 34. How many students liked Phineas and Ferb? Now this isn't only Phineas and Ferb, this is Phineas and Ferb. So in this case it's the 13 plus the 31, which is going to be 44. And so on and so forth. And that's how you do it. Okay? So sometimes you have to build your Venn diagram. Okay? If I look at this next one here, okay, sometimes you have to build it, and there are three things. In a survey, it was found that 38% of people, and it's talking percent of people, so 38% of people like cupcakes, 27% of people like pie, 10% like broccoli, and you can read it. So in this particular case, I've got a Venn diagram, I've got three situations. Okay? I've got a circle here, and that could be cupcakes. I've got a circle here, which is going to be pie. That's a P. And I've got a circle here, which is going to be broccoli. Okay? Now, you don't have to worry about the scale. But from there, then I say, okay, what do I know? And I usually start at the most restrictive situation, or the most detailed one. In this case here, that's the 1% liked all three at the bottom. 1% liked all three. This section here is all three. There's an intersection or region of the cupcake circle, the pie circle, and the broccoli circle. So 1% liked all three. So I've got that. We're all done. Now I work backwards, okay? Keeping in mind I'm starting with the most restrictive stuff. So 1% liked pie and broccoli. Pie and broccoli is this football-shaped region here. Okay? That's pie and broccoli. It should be 1% in total. Okay? So 1% are in this area. If 1% is already there, the remaining area has to be 0. Now, you could make a case then, well, you have to redraw the diagram because those don't match up. But I'm just going to leave it as numbers for now. So that's that. Okay? 3% like cupcakes and broccoli. cupcakes and broccoli is this football area here. That should be 3, so 3 minus 1 gives me 2. There are 2 that are only cupcakes and broccoli. They didn't like pie. Okay, and so on and so forth. 16%. I screwed up. This 0 should be here. Okay, because the 0, this 1% was pie and broccoli. That's this region. I'm sorry. Okay. Last but not least, now that I've got those 3, 16% like cupcakes and pie. Cupcakes and pie is this football here. Cupcakes and pie is there. Should be 16, so this is going to be 15 in that little area. Okay, and so on and so forth. Then from there I work back. 10% like broccoli. So this whole broccoli circle should be 10. I've got a 0, a 1, and a 2 there. So I've got 3% so far. The whole thing should be 10. So adding the 7, 10 minus the 3, that gives me that there are 7% that like only broccoli. Okay. Keeping in mind 27% like pie. Pie is this whole circle here. I've got 15, 1, and 0, or 16% so far. It should be 27%. So 27 minus 16 is going to give me 11. And last but not least, 38% of people like cupcakes. Cupcakes is this circle up here. So I've got 18 already. I need 38, so I need 20 there. And then from there you can answer questions. You can do all sorts of things. Okay? You've got 20% only cupcakes, 11% only pie, 7% only broccoli, all that sort of thing. Now keeping in mind the total percent should be 100%. So whatever it is, there are people that said they didn't like any of these. And they're outside. They're within my universal set, but they're not inside these circles. So 100 minus what I've got here. 100 minus the 15 minus the 20. I'm just going to add them up. 20 plus 15 is 35, 38, 39, 49, plus 7 is 56. So there's 44% that said they didn't like either of these, or any of these. So then from there, you've got this whole idea. Now, how did I know it was 100? It doesn't say 100 because I'm talking about percents, it's 100. If it's not talking about percents, then I have to take the total survey. Okay? So from there, using this Venn diagram, okay, you have the Venn diagram on you, so I'm just going to put it off over here. What percent like broccoli only? So broccoli only is this circle here, that's the 7, so 7% like broccoli only. What percent like pie and broccoli? So I go over here, pie and broccoli is here, so that's 0 plus 1 or 1%. Okay, that's what goes on here, so 0 plus 1 is 1. What percent of people like at least one of the items? So at least 1 is whatever's inside the circle. So we already added that up. That was the 56 I got before. Adding everything up, I get 56. And what percent like none? We've already got that, the 44. So on and so forth. That's how we end up doing this with the Venn diagrams. Now, Venn diagrams are really, really helpful at times. Going through and taking a look at those things is helpful. Keep in mind you have homework. Your homework for this lesson is on the notes attached to this. It's page 32 and page 51. So I hope that makes sense. Good luck. If you have any questions, come see me in class.